Good morning, lovely tenors. Right, buddies, here we go. Here we are in the next lesson in our sequence of lessons on sequences. How exciting. Your title for today, my lovelies, is Quadratic Sequences. Now, these you've not seen before. They're brand new for year 10, and they're actually quite an advanced skill that you're going to have here in year 10. They're one of those high grade, high tricky level ones. But my goal is you're going to be absolutely ace by today. So the thing is with this, I'm going to make this really hard before I make it really easy to start with. And you'll see why in the end. It's because I want you to see kind of where things come from rather than just me telling you. But that means I'm going to make this lesson a bit complicated, but then I'll back off and I'll make sure everybody understands how to do it at the end. Cool, okay. So to start with, my buddies, you are already ace at the ones that are called arithmetic sequences. They're the ones that just count on by a certain number every single time, okay? So it's like 2, 4, 6, 8, 10 is an arithmetic sequence because it is counting on a 2 every single time. Cool beans? And you're also good at finding the nth term of those. Now, not all sequences have to follow a rule of add and subtract, okay? And the type of sequence that we're going to do right now is called a quadratic sequence. So I'll show you what I mean by quadratic sequence. So do you remember what quadratic means, actually? Because you have seen that word before earlier this year. That's right! If you said that quadratic means it's got a squared in it, well, you're absolutely right. So we've done lots of stuff with quadratics this year. Largely, we've been factorizing them and solving them and stuff. That's what we've done so far. Yeah, so that means that if we've got a quadratic sequence, it's linked to a squared, so it'll be linked to n squared. Now, here's the thing. I can show you right now that you kind of can do this already, okay? You kind of can do them already. So if I said to you, I have a sequence and it goes 1, 4, 9, 16, 25, and I wanted you to tell me what the nth term is, or in other words, the position to term rule, would you be able to do that in this sequence? If this is the first, second, third, fourth, and fifth term in the sequence, what's the rule that links the red number to the blue actual value of the sequence? Well, what is that rule? Like, it's not adding the same thing on each time, because this would be +3, and then this would end up being +5, so, and then this would end up being +7, so it's not adding the same thing on, so that's not the rule. So what's the rule that links the red to the blue? If you said squared, you're absolutely right. So the nth term on this one is just this. It'd be u to the n equals n squared. So whatever number you're on, you just square it, and that gives you the value in the sequence. If you're on the fifth one, square it, 25. The third one, square it, 9. So boom, you've got your first ever nth term of a quadratic sequence, and you've done that with inspection without knowing any rules at all. Okay, also by inspection, buddies, I reckon you can do this one and this one, and I'm going to give you a great big pro tip, because this is actually going to be key to how we solve these in a bit. What I would suggest is, you know that this is the basic sequence, right? This is just squaring each one. I wonder if these ones are linked to that one in any kind of way. And the same deal here, if this one's linked to the top one as well. So have a little think, push pause, see if you can get the nth term for the other two. Okay, now let's see if you did. Now, just with inspection, I'll bet you did get it, because if you look at this one, so like, let's take this in blue, that compared to that, then this compared to this, well, what's the difference? What's happening? It should be a 1 and it became a 3, it should be a 4 but it became a 6, should be a 9 but it became an 11. Well, what it's doing is it's the same as the one above, so n squared, but they've just added 2 to every single number. So look, we've got another nth term on the go there. Okay, knowing that then, what's the bottom one? What's the rule there? It should be a 1, but it's a 4. It should be a 4, but it's a 16. It should be a 9, but it should be a 36, but it's a 9. It should be a 64, but it's a 16. How is it adjusted from the first sequence, from the un equals n squared one? Well, if you said it's 4 times bigger, that's right as well. So there you go, buddies. What you've just seen there is that you can come up with your own quadratic sequences, but what I also was hoping that you'd spot is that it is a bit of a faff, right? It's certainly not clear. Like, I bet some of you are quite good and figured this out quickly, but I bet you many of you are just like, I don't know what he's on about, and I don't know how he did that so quickly. And that's okay, because it is a bit of a faff, to be honest. If only there was a method that I was going to show you in a sec. Cool. Now, you can do them, these inspection ones, but look, it doesn't take too much for me to break it for you. I'll bet you, here, do it as a challenge, but I'm going to presume that nobody gets this. Pause it and see if you can come up with the rule for that. It's going to be something n squared plus something plus something. I'll bet you none of you get it. So push pause and have a think. And you would have found that actually, you might have been able to get the next term because this adds 4, and then this one adds, what does this one add? 7 to 13. This adds 6, and this adds 8, so it's adding 4, 6, 8. So the next one would add 10, and the next one would add 12. I bet you some of you could do that, but I'm not sure if anyone would actually be able to say what the rule is. And that's because the rule is going to be linked to a brand new method I'm going to teach you, which is called this, the method of second differences. Okay, so that's your subtitle. Now, this is the part that I told you I'm going to make it way harder than it needs to be to start with. And if it really stresses you, I want you to listen because it's good for you, okay? And it is kind of like an A-level skill to be able to do this and to work through it with me. But at the same time, if you find that this just confuses you and you get stressed about it, then there's a little black box at the bottom here. You can skip the video forward until I reveal what's under that black box, okay, buddies? But I do want to show you where it comes from. I'm not just going to make something up. Okay. Here's how the method of second differences works. This is kind of a proof or a derivation, but it's certainly not GCSE level, okay? This is A level, definitely level. So here we go. The nth term, if it's quadratic, is going to look like this, which I've got here in this square. Or I don't have it in a square, but what I have here in the middle, okay? It's an squared plus bn plus c. So in other words, it's going to be something n squared plus something times n plus something else. That's what it's going to look like, my buddies. If it's a quadratic sequence, it's going to follow that step. There's going to be an a and a b and a c, and we're going to have to work out what they are. Now, here's the whole entire trick to this, okay? If I can figure out what a is, buddies, if I can work out what a is, then that gets rid of this. I could get rid of this whole term, and I'd just be left with bn plus c. And when it's bn plus c, that's kind of like a linear one. So that's like 2x plus 3 or something, like what you guys are used to. So the only thing that makes this hard and horrible is this. If this wasn't here, this question wouldn't be horrible. So our goal then is to get rid of that. Now, I'm going to just tell you how under the box, but I'm going to prove to you how to get rid of the a. So are you ready? Here's what we're going to do. This is called the method of second differences. So to start with, you know how n is saying what term we're on, right? So like u1 is the first term, and that would mean that n is 1. Well, all I want you to do is put 1 in for the n's and see what comes out. So this would be a times 1 squared plus b times 1 plus c. Cool? Because I just put n in for what it was, because it was 1. Now this one here, like similarly, would be a times 2 squared plus b times 2 plus c. This one here would become a times 3 squared plus b times 3 plus c. And this one here would be a times 4 squared plus b times 4 plus c. Told you it was complicated, but watch, something cool happens. Okay, now watch this. Tidy it up. This just becomes a plus b plus c. Cool? This becomes 2 squared is 4, so 4a plus 2b plus c. This one becomes 9a plus 3b plus c. And this one becomes 16a plus 4b plus c. Okay, now here is the cool part. What we're going to do right now is what's called a first difference. Okay? And here's how it works. You just look between two terms and you subtract them from each other. So we're going to start with the further along term. So start with the n equals 2 term. That starts with 4a. And we're going to take away from it this first one. So here you go. 4a take away a is going to be 3a. 2b take away b is going to be plus b. And c take away c, well, it just disappears. Happy days, buddies? Okay, do the same on this one. Now we're going to subtract just the two next to one another. 9a take 4a is going to be 5a, 3b take 2b is going to be plus 1b, and c take away c, well, it just goes away. And the same deal here. 16 take away 9a is going to be 7a, 4b take away 3b is just b, and then c take away c is nothing. So that's what you're left with. Cool? So already something complicated is simplified down a bit. Here we go. Second difference. Now, second difference is the same deal. What we're going to do is we're going to subtract two terms that follow each other. 5a take 3a is 2a, and b take b is just nothing. 7a take 5a is just 2a, and b take b is nothing. Oh my gosh, every single one in the second difference simplifies down to 2a, my buddies. That means that if it was actual numbers, we could figure out we could do a second difference of those numbers, and it would always be the same. So it might be something like 8 or whatever, and then it would be like 2a equals 8, which means a equals 4. Which means we've got the first part of the equation. Oh my gosh. Okay, and here's where the other people are going to be rejoining me who skipped forward. It means this, my buddies. It means the second difference is equal to 2a. Okay, so good work for persevering with that, but I've just proved that that's the case, okay? I've shown you that a second difference has to equal 2a, which is the lead part of the nth term. I know it sounds complicated, but it gets way easier from here, okay? And here's what you actually do have to know for GCSE. So I'll stop being an A-level teacher for a sec and go back to year 10. Okay, so let's do it then. Here's that same sequence that we had a minute ago that made us unhappy. And watch this, my buddies. You're going to love it. Step 1 is you're going to do the first and second differences, okay? So first differences, what you do is you just subtract the ones that follow each other, okay? So 7 take 3 is 4, 13 take 7 is, oh god, what's that, 6, 21 take 13 is 8, 8. Cool? There's your first differences. Your second differences then, buddies, is going to be 2 and 2. So it's locked in. Cool beans, cool beans? That means, my buddies, it means that 2a is equal to the second difference, which is 2. See? I used the thing that was just on the last slide. I used that the second difference was equal to 2a. So that means that the second difference, which is 2, like this, is going to equal 2a, which means a is 1. Happy days? So a is 1. Which means, my buddies, that our answer is linked, and you have to write all of this, unfortunately. It's linked to, remember how we just said that it was a that was 1, right? That means it's linked to 1n squared, because it's the a that's touching the n squared. Are you happy? Okay, good. Now, it is tricky, but we're going to be good at it. Here's what you're going to do now, okay? Now it's just a matter of learning this pattern. So it's linked to 1n squared. So here's what you're going to do. Step 1 is you're going to rewrite the sequence in a little table, okay? So what's our sequence going to be? Well, it was 3, 7, 13, and 21, okay? The next thing you do is you write down your linked sequence underneath it, okay? So remember how we said it was linked to 1n squared because we figured out that a was 1. So it's linked to 1n squared. So we're going to write that sequence underneath it. So are you ready? Here's what I mean by that. Remember how here, I'm even going to write extra steps. I'm going to write extra steps, so you don't have to. This was the first term, that's the second term, that's the third term, that's the fourth term, right, buddies? So in 1n squared, let's figure out what we'd have to write. We'd have to write this. Well, n squared is 1, so it'd be 1 squared times 1, which is 1. The next one would be 2 squared, which is 4, times 1, which is 4. The next one would be 3 squared, which is 9, times 1, which is 9. The next one would be 4 squared, which is 16, times 1, which is 16. So that's what you've got, my buddies, is you've got these bad boys written out. We've got the linked sequence written out. Cool? Here's what you do next. You're going to subtract them. Okay, so we're going to subtract them. So 3 take 1 is 2, 7 take 4 is 3, 13 take 9 is 4, and 21 take 16 is 5. Here's what you've done essentially, my buddies. Because you knew it was linked to 1n squared, when we subtracted, we actually have eliminated this out of our answer. We've got rid of the n squared bit, and all that's left is the not n squared bit, which is that, and that matches up with these. And guess what, buddies? Now all you're going to do is say what the nth term is for these. And you can do that with your skills from last week. So what's the nth term that matches up with 2, 3, 4, 5? Well, it's this. The nth term that matches up with 2, 3, 4, 5, buddies, it's going to be this. Well, it's going to be, it's counting on in ones, right? So it's going to be 1n. And then if you went one back, it'd be like 1 secretly. Remember how we did that trick? You go one back. It'd be 1, 2, 3, 4, 5. So it's 1n plus 1. Okay, guess what, buddies? You've now done it. The nth term for that is this. The nth term that we left out was this. They go together. The two blue thingies go together like this. And the nth term for the entire sequence is this. It's the 1n squared plus the 1n plus 1. So I just put this one first and this one second, and they're written next to one another. Now I don't need the ones, so I'm going to bin them off. U to the n is n squared plus n plus 1. Bang. Your first ever really hard level quadratic sequence. Cool? Let's just check it to make sure. So this is like 3 should be the first answer, right? 1 squared is 1, plus 1 is 1, or sorry, so it's 1 squared plus 1 plus 1, so it's 1 plus 1 plus 1, which is 3, so it confirms. The second one, let's check it. 2 squared is 4, 4 plus 2 is 6, plus 1 is 7, so the second term works. And the third one, just for good measure, 3 squared is 9, plus 3 is 12, plus the other makes 13. So this rule has worked for all of the things written in blue. So this method has worked. Okay, I know this is hard, and I know that every single year students think it's really hard when they first learn it, but then think it's really good after they first learned it. So here's what I think you should do. I think you should semi-pause through this one. If you feel good, I'm going to say just go, pause me now, and go. If you're feeling okay, listen for a bit and pause when you think you can get ahead of me. So your goal in question E here is to pull ahead of me, okay? That's your goal. So push pause when you think you can. Cool. Okay, so everybody, here's what we're going to do. Step 1 is to find the second differences, don't forget. You get that by subtracting the two terms that follow each other. So let's do it. 11 take 8 makes 3. 16 take 11 makes 4. 5. And 23 takes 16 makes 7. Yeah, 7, 4, and 3, 7. Cool, there's your first differences. Get your second differences also. So, take them away. 5 take 3 is 2. 7 take 5 is 2. There's your second differences, buddies. The second differences are 2. Okay, because it stayed the same now. So then that means this. That means that your 2a is going to equal the 2. It's this 2 that it equals, yeah. The 2a equals the second difference, buddies. And what does that mean? Well, that means that a is 1. Cool? Which means it's linked to which quadratic expression? Well, it's linked then, because if a is 1, and they always are in this format, it means that a, it's linked to 1n squared, okay? It's linked to 1n squared, which is kind of our important part. It's going to be part of our answer, that. Cool. So what is it that we do next again? Well, if you said rewrite the sequence, you're dead right. Okay? So rewrite the sequence. 8, 11, 16, 23. Okay? Then what do you write? Well, you write your linked one. So you're going to write 1n squared, your linked one. Now you got to actually work out what that is, so don't forget there is a position in this. So it's 1, 2, third term, fourth term. Okay, 1 squared is 1 times 1 is 1. 2 squared is 4 times 1 is 4. 3 squared is 9 times 1 is 9. And 4 squared is 16 times 1 is 16. Cool? What do you do next, buddies? Well, if you said subtract, because that gets rid of the quadratic bit, that's exactly right. 8 take 1 is 7. 11 take 4 is 7? No. Yeah? Oh, 7. Oh, isn't that funny? 16 take 9 is 7. And 23, okay. Oh, isn't that weird? Okay. Well, there you go. You've got... you got a good one there, buddies. So here's something neat. It's just going 7, 7, 7, 7, 7. So actually, it's not got an nth term really, because it's going like, yeah, it's not got an nth term per se, because it's going on in zeros each time. Like the nth term of these guys would actually be 0n plus 7, because that'd be a 7 too. It'd be like 0n plus 7, which is just plus 7, right? So isn't that weird? That's cool, but that's how it's working. But what we've got here is a constant. So what's the nth term there? Well, there isn't really one. The nth term is, it doesn't matter what term you're on, the answer's 7. So if I said, what's the 8th term, you'd say 7. If I said, what's the millionth term, you just say 7. That means the nth term is actually just 7. Which means, buddies, when you whack these guys together, it's actually going to be a bit simpler than the last one. So even though it's kind of more complicated, it's actually simpler. Whack them together to get your nth term. Your nth term is simply going to be this. It's going to be 1n squared plus 7. Or just n squared plus 7. And that's your nth term. Cool beans, buddies? And that should work. Let's check it. 1 squared is 1 plus 7 is 8. 2 squared is 4 plus 7 is 11. 3 squared is 9 plus 7 is 16. It's working. That is the answer. Cool. So on this one, guys, I'm going to say to you, all by yourselves now this time, okay? So I want you to do it even if you're uncomfortable. I want you to try, and it's okay if you make a mistake. Go. Okay, and you're back. So let's see. Let's see how we got on. So the first step is the second differences, as you guys remember. So we're going to subtract terms that are next to one another. This is 8 take minus 5, so it's like 8 plus 5, which is 13. This is 27 take away 8, which is going to be, is that 19? I think so. Okay, and this is 52 take 27. 27 doubled is 54, so it's like 25, I think. Is that right? Is that in keeping? 25. Yeah, that is right. 25, nice one. Oh, my mental maths is the hardest part. And there you go, so happy days on them. Now, same deal again, second differences times buddies, and time buddies, and we're hoping it's the same number. 19 take 13 is 6. 25 take 19, thank goodness, also 6. Which means that's our second difference. Which means that 2a equals 6. Which means that a is 3. Okay? So it's linked to 3n squared. Now this one's a bit harder, but that's alright though. It's a bit harder, but let's do it. Okay, so now we're ready to go onto the table. What do you write in the table first, buddies? Yep, the sequence, you're right. Minus 5, 8, 27, 52. So what you write first is the sequence. Now, what do you write after that? Well, you write the linked one, which is 3n squared. Now, we're going to be a bit harder here this time, because it's going to be a bit more of a muddle to work this out. Third term, fourth term. So, got to follow BIDMAS. So to start with, you're going to do 1 squared, which is, so we're going to put 1 into the formula I've drawn in blue, or into this guy here on the left. We're going to pop 1 in. So square 1, you get 1, times it by 3, you get 3. Square 2, you get 4, times it by 3, you get 12. This one here, square 3, you get 9, times it by 3, you get 27. And then check out this one, 4 squared is going to be 16. 16 times by 3, 10 times 3 is 40, 6 times, 10 times, what am I doing again? 16 times 3, 10 times 3 is 30, 6 times 3 is 18, it's 48. That's it. Brilliant. Happy with our sequence. Okay, well the next step is to do a big old subtraction of the two, okay? Subtract. Minus 5 minus 3 is minus 8. 8 minus 12 is minus 4. 27 take 27 is 0. And 52 take 48 is positive 4. So there you have it. This is a bit of a tricky sequence, but it is working though, so that's brilliant. So what's the nth term of this sequence here? Well, it's adding on 4 each time, like it's doing plus 4 each time. So it's going to be 4n. And what would the one sneaky one be before the minus 8? Well, if you said minus 12, you've got it. Minus 12. So that's our nth term from this little part here. And guess what, buddies? That's it. That's as hard as they can possibly get. And all you do is you pop these two guys together, and there's your answer. U to the n is 3n squared from the first one, plus 4n, take away 12, all from the second one. And that's your answer. Let's check it just on the first one because the maths is getting a bit big here. But check out the first term. We should get minus 5 as the answer. So let's see if we do. 1 squared is 1. So this is going to be 3 plus 4, which is 7. And then 7 take 12 is minus 5. It has worked. Cool. So I hope you're okay on all of that. Very tricky. Here's what I'd like you to do. I want you to do as many of these guys as you possibly can. So hopefully all of them. And then when that's all done, take a picture of it. So you're just doing the nth term. I know they take quite a while. So you might only get maybe 5 of them done. But I would hope that it'd be kind of like at least 5 of them. And do pop around and try some of the hard ones too. I think the ones toward the end are definitely harder. This is attached on Show My Homework. When you get it all finished, my buddies, all I want you to do is take a photo, upload it onto Show My Homework or whatever your teachers asked you to do, and I guess that's it. So it's really tricky, but I'm going to give you tons of practice. We'll practice more and more and more next lesson too, okay? So this isn't the end of it. We're going to be practicing loads of these. Cool beans? Well, that's it from me then, my buddies, and see you next time. Bye, buddies!